Let me do one simple tutorial using Taylor series here. Example. Solve the function f of x equals to sine x at x equals to pi over 2 under Taylor series for a function of one variable. The question says that solve the function sine x. We have the value of x equals to pi over 2 for the function of one variable using Taylor series. One variable means that this is the function of one independent variable. We have only f of x, that is only x independent variable. So therefore it is a function of one variable. Solution. Let me put function here and functional value at x equals to pi over 2. Where the given function is f of x equals to sine x. And put the value of x equals to pi over 2. This is the value of x, which is pi over 2, and sine pi over 2 equals to 1. Substitute the value of x, which is pi over 2. Cos pi over 2 equals to 0. And then again take its derivative to have f double prime of x equals to minus sine x. Substitute the value of x, which is pi over 2. Minus sine pi over 2 equals to minus 1. Take its derivative again to have f double prime of x equals to minus cos x. Substitute the value of x, which is pi over 2. Minus cos pi over 2 equals to 0. So here the given function has been expanded up to third degree because the maximum derivative term is third derivative term. It depends on your question whether you wanna expand it up to third degree. You can also expand it up to fourth degree, up to fifth degree. It depends on you. If you want to expand it up to fourth degree, your maximum derivative gonna be fourth derivative term. Up to fifth degree, you're gonna differentiate the given function 5 times. It depends on your given question. From the formula of Taylor series where f of x equals to f of a plus x minus a over 1 factorial times f prime of a plus x minus a to the 2 over 2 factorial times f double prime of a plus x minus a to the 3 over 3 factorial times f triple prime of a. Look here, I have only 4 terms in this formula because the given function has been expanded up to third degree. The maximum derivative term here is third derivative term. The more you have derivative terms, the longer you're gonna have the Taylor formula. So this formula is based on the above table. Substitute the values here where the value f of a is 1 here. F of x is actually f of a. The value of a is pi over 2. A is actually the value of x, which is pi over 2. F prime of a is 0. A is pi over 2 again. F double prime of a is minus 1. The value of a is pi over 2. F triple prime of a is 0. These are the values that I just substituted in the formula. Simplify the equation further to finally have f of x equals to 1 minus x minus pi over 2 to the 2 over 2 factorial. This is my final answer for the given function when I expand it up to third degree using Taylor series.